Have you ever looked up at the night sky and wondered if we're truly alone in the universe? For generations, people have gazed at the stars, curious about the possibility of life beyond Earth. Well, that curiosity may have just paid off. The head of NASA has announced a stunning discovery made by the James Webb Space Telescope, JWST, something that could change everything we thought we knew about life in the cosmos. And yes, it involves Proxima B, a planet far, far away that might just hold the clues we've been searching for. The James Webb Space Telescope is the most advanced space observatory ever launched. Positioned perfectly in space, it allows scientists to study distant stars, galaxies, and exoplanets in ways that were never possible before. Its powerful technology is truly reshaping how we explore the universe. One of JWST's standout features is its massive primary mirror, which is much larger than that of the Hubble Space Telescope. This allows it to capture even the faintest light from incredibly distant objects, light that Hubble simply couldn't reach. Thanks to this mirror, JWST can see deeper into space and in far more detail than ever before. The telescope also comes equipped with revolutionary instruments like the near-infrared camera and IR-cam, which captures images in the near-infrared spectrum. This is important because infrared light can pass through cosmic dust clouds that block visible light, revealing the hidden processes of star and galaxy formation. With NIR-cam, we can see stars being born and peer into the heart of galaxies to learn about their formation and evolution. Another powerful tool on board is the near-infrared spectrograph, NIR-spec. It splits incoming light into its component wavelengths, a technique known as spectroscopy. This helps scientists determine what distant stars and planets are made of, how hot they are, how fast they're moving, and much more. With NIR-spec, researchers can study stars and galaxies in detail, tracking their life cycles from birth to death. JWST also uses the mid-infrared instrument MIRI, which observes even longer wavelengths. MIRI helps us examine cooler objects like dust clouds, forming stars, and planets. It can also analyze the atmospheres of exoplanets, looking for signs like water vapor, carbon dioxide, and methane, all of which could hint at the potential for life. When searching for life on exoplanets, JWST primarily relies on two techniques: spectroscopy and atmospheric analysis. Even if a planet doesn't have Earth-like conditions, these tools can still detect the chemical fingerprints of life. When a planet passes in front of its star, the starlight shines through the planet's atmosphere, and JWST analyzes the light that comes through. This helps identify what molecules are present, which can tell us that the planet might support life. Both MIRI and NIR-spec work together to cover the full infrared spectrum, giving scientists a complete view of a planet's atmosphere. By detecting specific gases, like oxygen, methane, and water vapor, JWST provides critical clues about whether a planet could be habitable. Another groundbreaking method used by JWST is comparative indicator spectroscopy, which involves comparing the light from different planets. This helps scientists identify patterns and anomalies that could suggest biological activity. So, what's the big news about Proxima B? While details are still emerging, early data from JWST hint at atmospheric elements that could support life. It's not proof yet, but it's a major step forward. Further observations will be needed to confirm whether the planet is truly habitable or even home to alien life. Beyond the search for life, JWST is transforming our understanding of the universe. It's allowing us to see galaxies as they were billions of years ago, offering insights into the early universe. It's helping scientists study how stars and planets form and evolve, and how galaxies are built and change over time. With its unmatched sensitivity and range, JWST is also revealing objects previously hidden behind dust, like newborn stars and forming planets. These discoveries are helping us piece together the grand story of the cosmos. Looking ahead, the James Webb Space Telescope will continue to lead the charge in space exploration. Its discoveries could revolutionize space travel, our understanding of life, and the nature of the universe itself. In short, JWST is a game changer. It can analyze distant galaxies, hunt for habitable planets, and search for the building blocks of life, all in stunning detail. As it continues its mission, this telescope is not just showing us the universe, it's helping us understand our place within it. What do you think of these discoveries? Drop a comment. like the video, and don't forget to subscribe for more cosmic updates. See you next time. One of the most exciting features of the James Webb Space Telescope JWST is its ability to look back in time and observe the early universe. By capturing light from the first galaxies formed after the Big Bang, scientists can study the origins of the universe and track its evolution over billions of years. This helps us understand how the cosmos has changed and continues to change on a grand scale. Thanks to its advanced instruments, JWST can see farther back in time than any telescope before it. It detects faint light from galaxies that formed billions of years ago, offering us an unprecedented view of the universe's beginnings. The data it collects is set to revolutionize space exploration. As astronomers continue analyzing light from stars, galaxies, and exoplanets, they're likely to make discoveries that challenge our current understanding of the universe, possibly even reshaping how we see our place in it. This telescope marks a major leap forward in humanity's quest to answer the big questions about space. For centuries, humans have looked at the stars and wondered if we're alone in the universe. Now, that question may be closer to an answer. Recently, NASA officials revealed that JWST has detected something extraordinary, possible signs of life on a planet called Proxima B. If confirmed, this would be a groundbreaking moment in human history. JWST is packed with cutting-edge technology that's truly transforming our view of the cosmos. One of its standout features is its massive 6.5-meter mirror, significantly larger than the Hubble Space Telescopes. This allows it to collect extremely faint light from distant objects, enabling astronomers to observe areas of the universe that were previously hidden. Beyond its giant mirror, the telescope has several sophisticated instruments. One of them is the near-infrared camera and IR cam, which captures images using near-infrared light. This is crucial because infrared light can pass through cosmic dust clouds that block visible light, allowing scientists to peer deeper into space. NIRCam's high-resolution imaging lets astronomers study how stars form within galaxies in incredible detail. Another key tool is the near-infrared spectrograph, NIR-SPEC, which splits light from distant celestial objects into different wavelengths. This helps researchers determine the temperature, composition, and movement of stars and galaxies, vital data for understanding their behavior and structure. The mid-infrared instrument, MIRI, studies even longer infrared wavelengths. It's especially useful for observing the dusty regions where stars and planetary systems are born. MIRI also plays a critical role in studying the atmospheres of exoplanets. By analyzing their infrared light, it can reveal what these planets are made of, how hot they are, and whether they might support life. These dusty star-forming regions are normally invisible in regular light, but infrared light can get through. With MIRI, scientists can watch stars and planets forming in real time. It also excels at detecting exoplanets by capturing faint infrared signals from their atmospheres, searching for key indicators like water vapor, carbon dioxide, and other potential biosignatures. To search for life, the JWST relies on techniques like spectroscopy, the study of how matter absorbs or emits light. When an exoplanet passes in front of its host star, some of the starlight filters through the planet's atmosphere. JWST analyzes this light to detect chemical fingerprints that might point to life, even if that life doesn't produce oxygen or photosynthesize. The James Webb Space Telescope, JWST, is opening up a new era in space exploration, especially when it comes to studying the atmospheres of distant exoplanets. When a planet passes in front of its star, it leaves behind chemical clues in the starlight. Scientists can study this light to learn what's in the planet's atmosphere. To do this, the telescope uses instruments like MIRI and NIR-SPEC, which cover a wide range of infrared light. This helps scientists gather detailed information about the planet's chemical makeup. One of the telescope's main goals is to search for biomarkers, chemicals that may be linked to life, such as oxygen, methane, and water vapor. However, finding these biomarkers is just the beginning. More observations are needed to determine if a planet is truly habitable or shows any real signs of life. To improve the search, JWST uses a technique called comparative indicator spectroscopy. By comparing light data from different planets, scientists can better assess the chances of life existing elsewhere in the universe. So, what do you think about this exciting research? Leave a comment below, and if you enjoyed the video, give it a thumbs up and subscribe. The James Webb Space Telescope is a major leap forward in the search for life beyond Earth. Its powerful instruments allow it to view distant planets in incredible detail. As scientists continue to analyze the data, they're learning more about the potential for life elsewhere. But JWST isn't just about looking for life. It can also look back in time by capturing light from galaxies that formed billions of years ago. This helps us understand how the universe evolved, how stars and planets were born, and how everything is connected on a cosmic scale. By taking detailed images of galaxies, stars, and other celestial objects, JWST is helping scientists piece together the universe's history. It's constantly challenging what we thought we knew and inspiring new ideas about space exploration and the possibilities that lie ahead. Thanks to its ability to observe in both near and mid-infrared light, JWST can peer into dusty regions of space to see things that other telescopes can't, like stars being born or planets taking shape. This infrared capability also helps scientists study how stars live and die, and how galaxies form and grow over time. One of the most exciting possibilities is JWST's ability to detect light from the earliest galaxies formed after the Big Bang. This could offer clues about how the universe began and how it has changed over billions of years. With every observation, the James Webb Space Telescope is changing how we understand the universe. Whether it's spotting exoplanets, uncovering hidden star nurseries, or tracing the origins of galaxies, JWST is paving the way for future discoveries. It's more than just a telescope. It's a time machine, a life seeker, and a cosmic storyteller. As we venture deeper into space, this remarkable instrument will remain at the forefront of discovery, shaping our understanding of the cosmos and the future of space travel.